So first of all, welcome to everybody from Malaria Consortium. Obviously, we're all remotely scattered around the world at the moment and in our own homes and largely presenting from there. Thank you very much for attending this seminar, The Next Generation of Entomologists, What the Future Holds. And my task is to do a brief introduction to Malaria Consortium and then hand on. So actually, if we can do the next slide, please. So our agenda for today, I'll do a short introduction. I'll hand to James Tibentarana, who will talk about Sylvia Meek and the setting up of the scholarship, and then we'll hand over to our scholars to present their work and what they've got to, and then there'll be a time for question and answer and some closing remarks from Carrie Brown, who is Sylvia's sister. So that's our agenda for today. Oh, people continuing to roll in, so welcome to all of you. And again, Ashley, if we can then move on to the next slide, please. So Malaria Consortium, we are one of the world's leading specialist non-profit organizations, and our mission is to improve lives in Africa and Asia through sustainable evidence-based programs that combat targeted diseases and promote child and maternal health. And it's been our great privilege over the last few years. We've had a number of business areas. One of those is about vector control. And we've been able to work with the scholars you're about to hear from in one of those areas of vector control about the work that we've been funding through the Dr. Sylvia Meek Scholarship. So with that, we move to our map. You'll see we work across what is really the malaria belt in Africa and Asia. You'll find us where malaria is or was. And we've worked in a number of other countries as well. This is our current portfolio, working across much of sub-Saharan Africa. And we've, worked in many other places as well, and in Southeast Asia, where we're active at the moment in the countries that you see there. So with that, I'll hand to James, who will talk to us about Sylvia and the basis of the scholarship. So James, over to you.
Thank you very much, Charles, and good morning to all of you. I'll just say this very briefly and then go to some reflections. With Sylvia's family, we were able to set up a scholarship fund as part of her legacy. And that scholarship led to us setting up a scholarship for entomology at the University of Mahidol in Thailand, the University of Nigeria in Suka, and the University of Pretoria in South Africa. And we have been fortunate that through this scheme, we've been able to host 7 scholarships so far, of which we're going to listen to some scholars who have completed their masters in entomology, and 2 others who are still going through their master's course. We hope that subsequent in the near future, we might be able to hold a few scholarships. And I hope that when you listen to the scholars and hear the enthusiasm, you will sort of see the attributes that Sylvia meant or carried with her. And so I'll give you a number of reflections about Sylvia. And I hope this will be important for the scholars as they move forward in their careers. I periodically use these reflections myself, and I suspect that others who knew and worked with Sylvia will recognize some of her attributes. Sylvia believed in doing good science and was keen to generate evidence that could make a difference to people's lives. We used to discuss whether the priority was how many papers we published or the quality of the few publications. And consistently, she emphasized quality over quantity. However, that was not enough. It was important to Sylvia that evidence is understandable to those who should use it, and the implications of evidence is sufficiently well described. Having a sense of purpose was always important to Sylvia. As the Malaria Consortium, our mission should be one that is meaningful to us and adds value in the lives of our beneficiaries. The technical details are essential, and in addition, clarity of the bigger picture. How do the pieces come together to achieve a greater good? How do we make evidence count? Despite the hard work, Sylvia found the time to enjoy culture, nature, cuisine, and being with people. She made friends everywhere she went. Anyone who met Sylvia was struck by her ability to simplify complex information. She made disease control and public health understandable. Her impeccable grasp of the English language was amazing to experience. She always did the executive summary of our technical documents. Sylvia was an influencer throughout her career, and I believe it was because of her effective communication skills, which includes being a good listener, her extensive networks, her diverse technical knowledge, and her evidence-based approach to public health. Every life matters, every life is precious. Thinking about solutions from the bottom up and making evidence relevant to those who experience the burden of ill health. Understanding the sociocultural determinants without prejudice. These were all important to Sylvia. Sylvia carried a map of London with her, and I believe she always carried a torch as well, a pocket torch. I think the map and torch were a sign of the willingness to adapt and respond to the context even when one is lost or in unfamiliar territory. This is a reflection that is pertinent in the current context of the COVID-19 pandemic. By making optimal use of the tools we have and the information we gather, we should be able to navigate our way through. I hope these are reflections that are meaningful to you because they are meaningful to me and my colleagues. I would now like to ask the first presenter to tell us about their work. And I'll start off with Takalani, who did her master's at the University of Pretoria in South Africa. Over to you, Takalani.
Can you hear me now?
Yes, we can.
Oh, thank you. And thank you for the introduction. So the title of my research was Effectiveness of Cattle-Administered Endecticides to Reduce Malaria Vector Mosquitoes. Next. Okay, so malaria control primarily depends on indoor residual spraying and long-lasting insecticide-treated nets. However, these two strategies have been losing their effectiveness. Since 2015, the number of malaria cases have been on the rise. So some of the factors which are challenging the two strategies are the physiological resistance that is continuously developing in some of the vectors, which causes the vectors to escape the two strategies. Some of the vectors also now prefer to bite outdoors when people are not under their nets. And then also there's a temporal shift that has been noted in biting behaviors of some vectors, whereby some of the mosquitoes prefer to feed in the late mornings and early evenings when people are not under their nets. And also some of the malaria vectors are feeding on animals, which causes their vector density to increase. So given all these challenges, this calls for development of new malaria control strategies. Next. Endecticides are a potential malaria control strategy which might be implemented in the future. So endecticides are drugs that are already there in the market, and they're used to control parasites such as worms and ticks in livestock. So apparently these endecticides are also effective against malaria vector mosquitoes. Next. So in the future, these endecticides might be used to control vectors such as Anopheles arabiensis, which now prefers to feed outdoors, and also instead of just feeding on the humans, also feed on animals. However, there are limited field studies that have investigated the use of livestock administered endecticides. Next. This led to the aim of my study, which was to investigate the effectiveness of two endecticides, which were ivermectin and fipronil, on the survival and fecundity of Anopheles arabiensis. Next. Some of my objectives were to determine that ivermectin and fipronil reduce the survival and egg production of Anopheles arabiensis, to compare the efficacy of ivermectin against that of fipronil, and to assess the duration efficacy of each endecticide. Next. So for my experiments, I had 6 cattle, 2 of which we treated with ivermectin, 2 with fipronil, and 2 were left untreated, and they were my controls. So we placed female Anopheles arabiensis mosquitoes in polystyrene caps, which we covered by netting, and we allowed the mosquitoes to feed from the kettle for a period of 15 minutes. After that, we separated the unfed from the fed mosquitoes, and we took the fed mosquitoes back to the lab, and we monitored them for motility and fecundity on a daily basis. Next. These are my main results. The red represents ivermectin, the green is the fipronil, and the blue is the control. On the y-axis is the mean percentage mortality, and on the x is the days post-feeding. So ivermectin was more effective than fipronil and the control, as you can see the red on the graphs. Both endecticides were effective for a period of plus or minus 21 days. Next. For the eggs, both fipronil and ivermectin were able to successfully suppress the egg production. However, ivermectin was more effective than fipronil in control, as you can see from the graphs. Those were the mean number of eggs that we produced over the study. Next. So from my study, we can conclude that endecticides are able to reduce the number of mosquito vectors, Anopheles arabiensis in this case. But however, we are worried about the short term of 21 days. So this leaves us questioning the strategy of endecticides as an effective malaria control strategy. So if endecticides are to be used in the future, they must be used strategically. So methods to increase the duration of effectiveness of this endecticides must be found. There is one potential strategy that is currently being investigated, which is the use of slow release implants formulation. So this strategy causes the endecticides to remain longer in the blood and also to be effective for a longer period, but this strategy is still being investigated currently. So we should also focus on developing other strategies in the future. Next, I would like to acknowledge the Malaria Consortium for funding the project, and I also like to acknowledge my supervisors for their support and guidance. Thank you.
Thank you very much, Takalani.
Thank you.
Just to say that if you have any questions, please could you put the questions in the question and answer chat. In addition, we will have a question and answer session after all the presentations where we'll take out some of the questions and hopefully get some responses. We'll also be getting a few comments from some of the participants who I will draw in to the discussion. Just to stress that the controls will be managed centrally, but I do think if you do want to speak, there's also the opportunity to unmute yourself. So moving on to the next presenter, Adnan will be did his master's at Mahidol University, is going to give us the next presentation. Over to you, Adnan.
Thank you so much, James, for introduction for me. So my name is Mohammad Adnan from Pakistan, and today is my topic, comparison of effective dose with protection time for 3 botanicals by using multi-chamber blood feeding system against Aedes aegypti. Next, please. My outline includes introduction, objectives, material and methods, result and discussion. Next, please. Click this. Repellents as typically performed on shaven animals such as rabbits. However, these techniques often raised queries concerning the ethical treatment of animals and humans, as well as practical aspects that sometimes cause the result of repellent tests to be misconstrued. To overcome this situation, please the previous one. To overcome this condition, we developed a novel repellent testing which required less number of mosquito and less contamination and evaporation chances. Next slide, please. My objective is to select candidate herbal mosquito repellents by using multi-chamber blood feeding test system against Aedes aegypti. The second objective is to evaluate the effective dose, ED50, and median complete production time among repellents. Next slide. Material and method. Study area Kanchanaburi. The testis mosquito is Aedes aegypti female mosquito 5 to 7 days old. A preparation of multi-chamber blood feeding system, preparation of impregnated net and blood feeders. Next slide, please. This is a multi-chamber phase. Each time of the repellent test is composed of 6 chamber A to F. The green color chamber is used for control and the rest of the chamber is used for different concentration of the botanicals. Next slide, please. Procedure 1. There are total 3 procedures. The first procedure is test the readiness of the equipment. Objective to test the readiness of the equipment and biting stimulated factors, blood parafilm, mosquito status, sunlight, cuffs. So each chamber is replicated or tested 2 times to know the status of the equipment. Equipment is ready for the real experiment or not. Duration is approximately 15 to 20 minutes and types of the net, no using net. And the second procedure is for control, that we use the impregnated with the ethyl is methanol, and the third one is the three botanicals and one DEET with 5 different concentrations. Next slide, please. And this is a method. First, we label on the cups, and the second, record environmental data. First, start time, temperature, relative humidity, mosquito age, and third one is uncover plastic wrap of every chamber. Next slide, please. Fill 2 ml of blood into each. Next slide. Put mosquito cup into the chambers, put the feeder on the cups, cover plastic wrap of the chamber. Third step was done ordinarily from chamber A to F. Next slide, please. Record number of successful mosquito within 3 minutes. After testing all the tested mosquito kept for mortality status for 24 hours. After 24 hours, we recorded the mortality. All the mosquito was terminated 20 degrees centigrade for 24 hours, and after that we discard the mosquito. Next slide, please. And our data was analyzed by Kruskal Wallis test used to compare among the different concentrations of the different repellents. Rij is the rank among all observations of the observation from J from group I. N is the total number of observation across all groups. Next slide, please. This is my result. So if we compare the botanicals with the DEET, so botanicals we use 5 different concentration, except citronella we use only 3 concentration because 75% and 100% can dissolve the parafilm. So that's why we just focus on the first 3, 10, 25 and 50% of for citronella. So if we compare in the first 10% 3 botanical with the 0.01 DEET, so there is a significant difference between all the different botanicals. And if we compare 25% to 0.25% DEET, so there is also a And if we compare 50% to 0.5% DEET, so there is also a significant difference between citronella and other rest of the repellents. And if we compare 75% and 0.75%, so this result is non-significant, and 100% also showing non-significant, but DEET is significant. Next slide, please. So this is a graph showing the highest protection time was recorded on 50% citronella, which is 240 minutes. And the second highest time was recorded on DEET, which is 2.5, which is very less, but it can protect more compared to botanicals. Next, please. The second highest time was recorded on 150 minutes, which is on lemon eucalyptus. 100% protect 150 minutes. Next, click this. And the third highest time was recorded 150, which is the DEET is 0.75% can protect 120 minutes. Citronella 10% can protect 120, and lemon, eucalyptus, and citronella lavender 75% can protect 120 minutes, and lavender 100% can protect 120 minutes. Next, click this. The 90% 90-minute protection was recorded on lemon, eucalyptus, and lavender is 50%, and 0.50% protect 90 minutes of DEET. Next, click this. So this is the dose response to mortality after testing with the botanical the graph. So there is not so much mortality was recorded, more than 2.5. Only citronella 50% can mortality is 2.3% only, and control there is no mortality was recorded, and the rest of the mortality was not more than 2%. Next slide, please. So these are the effective dose which was calculated by log design. So the first one shows the lemon eucalyptus, which is 35.48% required to protect the 50% of the testis mosquito, and the second one is lavender oil, which is 39.81% required to test the 50% of the mosquito population, and the third one is the citronella, which is required 13.48% to repel the 50% of testis mosquito, and for DEET 0.5. Botanicals, citronella is the highest effective, and if I compare with the DEET, so DEET is the still effective against among all the other botanical repellents. Next slide, please. Acknowledgement. First of all, I would like to thank Malaria Consortium who supported my study throughout the year, 3 years almost. And first, I would like to thank Dr. Sylvia Meek, and second, I would like to thank my major advisor, Sankit Sanwal, who helped me in my study design and my experiment. And the third one, I would like to thank my co-advisor, Jamnan and Rachareen Potiwar. Next slide, please. Thank you so much. Any question?
Thank you very much, Adnan. We'll take the questions at the end of all the presentations. All right, moving on. Thank you very much. Moving on to Fumilayo, who did her master's at the University of Nigeria in Nsukka. Over to you, Fumi.
Okay. Hello, everyone. Can you hear me now?
Yes, we can.
Hello. Okay. Good afternoon. Okay, I'll be presenting my master's thesis, and my topic was ovicidal, larvicidal, and repellent activities of ethanolic leaf extracts of 3 botanicals against the malaria vector Anopheles gambiae. Next slide, please. It is no more news that malaria is a major public health concern in the world. Apart from the current COVID-19, it still remains a very, very great problem for public health researchers And globally, malaria has infected over 500 million humans. And in sub-Saharan Africa, we have 3 children that now die of malaria every 2 minutes. And in my country, Nigeria, the entire population of over 180 million is at risk. And the most important vector of malaria in Africa is the Anopheles gambiae. Various researchers, they have gone through various control strategies, just like the cultural, the physical, the biological, and including the chemical method, which is the most common one now. And the most common vector control strategy in Africa is the use of the ITNs, that is the insecticide treated nets. That is what we use basically in Africa, and it is very, very common. Next slide, please. But the repeated use of this insecticides have caused, it has caused more harm than good. It has caused a lot of environmental pollution, health hazards, including the destruction of non-target organisms like other insects. They have been affected by this insecticide. And the major problem that we have currently is the development of resistance in the vector. So there is probably a need, there is an urgent need to look for other ways where we can to look for other ways to control this these mosquitoes. So over the period, like about a decade ago, scientists discovered that there are some plants that possess some primary and secondary metabolites that have this insecticidal properties. So they just hypothesized that, okay, plants could actually provide less toxic, environmentally friendly, and easily degradable vector control measures. So in Nigeria, in the northern part of Nigeria, we discovered that some of these northerners, that is the villagers, they use plants traditionally to control mosquitoes. So we went there, we gathered about 3 plants, and we decided to focus on evaluating the ovicidal, the larvicidal, and the repellent activities of 3 plant extracts that we gathered from the northern part of Nigeria against the malaria vector, so we can establish a fact, maybe they can be used as a potential insecticide in the future. Next slide, please. Next slide. So we gathered 3 plant extracts. The first is the Directa erecta, commonly known as the sky flower. The second is the Tridus procumbens. We call it, so please go back, please. Go back to the previous slide, please. Previous, okay, good. So the third one is the Penicillium purpureum, commonly known as the elephant grass. It is a very common grass in Africa. So the very first thing that we did, we gathered the plants and identified. We moved on to the lab to extract the plant extract using ethanol. We soaked it for 72 hours. Then immediately after that, we concentrated the plant extract using the rotary evaporator. Next slide. Next slide. Okay, the test organism Anopheles gambiae, we purchased the egg for the Anopheles gambiae at a research institute at the University of Nigeria, Nsukka. Then we took the eggs to the lab, we reared the eggs into larvae, and we reared some into adults because we performed both. We performed the ovicidal, we performed larvicidal, and also the repellent activities of the 3 plant extracts. Then immediately after that, we also prepared the plant extract solution for bioassay. So we used the WHO standard to prepare the plant extracts for each of the plant materials that we gathered. Next slide. So the first thing we did, we performed the ovicidal bioassay. Then for each of the bioassay, we add about 4 concentrations. That is 4 aliquots of each of the extracts. We add 1.0, 1.4. We add 0.5 and also 2.0, just to determine the concentration at which each of the extracts will be more effective. And we add a control of only ethanol because we used ethanol to mix as, we use the ethanol as the solvent. So each of the containers, that is what you have in the first slide, add 25 eggs each, and also 25 larvae for each setup, for each experimental setup. And for the repellent activities, we made use of eight volunteers, and we compared it with the common repellent that we have, that is the DEET, that is DEET. So we compared it to check the one that is most effective. So we gathered the three data and we subjected the data to statistical analysis. We made use of ANOVA. We used the post-hoc test to determine the significant differences between the three extracts, and we also checked the lethal dose concentration using the probit analysis. So that was what we analyzed using the three bioassay. Next slide. So we had lots of results. So I'll try to summarize my results. We actually also conducted a phytochemical screening for the three plants, and we discovered that these three plants, they revealed the presence of alkaloids, flavonoids, tannins, and saponins. And especially saponins, the presence of saponins in these three plants actually revealed that they can be used as insecticides, because including flavonoids and alkaloids, because we checked various researchers and various works, and we discovered that most of the plants that are being used contain all these extracts. I mean, the phytochemicals. So we also discovered that the three plants partially inhibited the hatchability of the eggs. Most of the eggs were unable to hatch due to the presence of the plant extract. And also for the larvicida bioassay, most of the plants actually inhibited the growth of the larva. So it actually made the percentage of mortality to increase. But among all the three plants, we discovered that D. erecta, also known as skyflower, was more effective, was the most effective extract in the experiment. Next slide. So this is just part of the result, like the result summary. For the hatching rate, we discovered that D. erecta reduced the hatching to 12% compared to T. procumbens and P. purpureum, that is the elephant grass. And for the mortality rate, we discovered that D. erecta increased the mortality rate of the larva over 50%. The same thing applies to the repellent rate. And for each of the control, we discovered that the control were significantly different from the test group. So we can actually conclude, please, next slide. Next slide, please. The list of the T. erecta, T. procumbens, D. erecta, T. procumbens, and P. purpureum, we discovered that they contain insecticidal compounds, which I explained the other time. And these plants can be used. We discovered that they can be used for development of easily biodegradable insecticide, which will serve as best alternatives to the environmentally hazardous ones available. We have a lot of environmentally hazardous ones available, including the ones that are already been established as resistant, as the ones that are that are already resistant against the Anopheles gambiae. Next slide. Thanks for listening. And I also want to appreciate Malaria Consortium for the opportunity. Thank you so much. Thank you.
Thank you, Fumilayo. Okay, please keep the questions coming in the chat. And also, as I said, we'll have a question and answer session and a couple of comments from some of you. We'll now move to Wulan, who's also from Mahidol University, sorry, who did her master's in Mahidol University, and is going to take us through her findings. Over to you, Wulan.
Can you hear my voice?
Yes, we can hear you.
Okay. I'd like to thank you for this opportunity. So I'd like to talk about my thesis entitled diversity and geometric morphometrics of chica mites at public parks in Bangkok. Next slide, please. Next slide, please. Okay. So we all know that scrap tivus is distributed in the triangle of the Sugamuxi area, and Thailand is one of the countries that lies on that triangle area. And if you take a look in Bangkok as metropolitan city, yes, it still have some cases of scrap tivus in Bangkok. Next slide, please. Oh, well, usually scrap tivus found in rural areas, but in the past, scrap tivus serial survey in suburban of Bangkok found the evidence of scrap tivus transmission in this metropolitan city. Other example is in China, in Guangzhou, China. Scrap tivus cases also related with the activities in the city park. Next, please. All right, to understand more about scrap tivus, take a look on the chica mites life cycle. So the only parasitic stage is larva stage that we call as chicas or chica mites that usually feed on vertebrate hosts, for example, rodents as the reservoir host. Next, please. Okay, this is the framework of my study. It is divided into 3 different colors, means 3 different objectives. Next, please. All right, so my first objective is to define the diversity and host factor relationship of chica species among public parks in Bangkok. So from the objective fund, the results are more than 11,000 chicas were isolated from 164 rodent years, and most of them, around 80% of the reservoir hosts that captured was Arabtostratus complex. And then the chica's infestation prevalence on rodent is more than 73%, which is quite high in metropolitan city. And in terms of chica's diversity, because we found only 2 species, Ascochygastia indica and Leptotromidium deliense, so the diversity of chicas is low. Next, please. Okay, this is my second objective, to apply landmark-based and outline-based geometric morphometrics to study size and shape of chicas using the scotam. In this case, we use the sample of Ascochygastia indica. So we do the GM or geometric morphometrics for intra-species. Why? Because in this intra-species, in this Ascochygastia indica samples, we found it has 2 different shape of sensili, as I point in the blue arrow in the green pictures. So the sensili is different. So after we did the GM analysis, it showed significantly different in scotum size and shape in terms of intra-species for Ascochygastia indica. So it might be different species, or it might be morphological plasticity. We still don't know. That's why for further study, for the further research, we suggest to do molecular identification to confirm this. Next, please. All right, this is my last objective, to describe potential vector by Orientation Sugamuxi screening in chicas. So we screen for 80 pools of chicas. All of them are negative from Orientation Sugamuxi. So Orientation Sugamuxi is the agent of scrap tivus. Okay, next, please. Okay, so this is the conclusion. So from our study, it shows that at public parks in Bangkok, it has high chicas infestation prevalence on rodents, but quite low diversity of chica species. And the good news is there is no chicas that infected with Orientation Sugamuxi. It means that cases in Bangkok is not locally transmitted in Bangkok, but probably it is transmitted from or imported from other provinces, but then recorded in Bangkok. Okay, next. Yeah, thank you very much.
Thank you very much, Wulan, for that presentation. And then we'll now move on to Amos, who also did his master's at the University of Nigeria in Nsukka. Over to you, Amos.
Thank you. I'll be talking about my topic, which was molecular identification of Aedes mosquitoes in Nsukka local government area, Nigeria. Next. Aedes mosquitoes are potential vectors of several viral diseases, much of which have been reported in Nigeria. And also studies have shown that actually these vectors are abundant in the southeastern parts of Nigeria. So this study specifically explored the Aedes mosquitoes which are present in the region. And also given the fact that much of the previous studies have relied on conventional identification techniques, and less has also been geared towards using molecular methods. Next. Next, please. So the general objective of this study was to determine the Aedes mosquito species present within Nsukka local government area, particularly investigating the breeding habitats and using morphological method to identify Aedes mosquito samples and use an area-specific application method to discriminate the Aedes species. Next. Yeah, so this study was carried out mainly in two selected autonomous committees of the local government area. These ones were chosen based on the ecological and demographic characteristics. Next. Next, please. So here is the map showing the two autonomous communities. On the left is the map of Nsukka local government area. And the dots are actually sampling points which were referenced during the sample collection. Next. Now, three methods were employed for this study. These ones included larval sampling and the use of human learning catches and the big sentinel traps. This was a cross-sectional study, and I can say the HLC, which was used in this study, was actually a modified method where the researcher and the research entomologist who assisted in this study, we used some kind of a modified method where you use the test tube to capture the mosquitoes. And also the lab was collected at in the video household level from the selected autonomous committees. Next. Next, please. Now, the mosquito breeding habitats were actually recorded, as I've said, and referenced. Now, the mosquito larval samples which were collected, they were dispatched to the laboratory that was at NAVAC for rearing product stage. And the adult mosquitoes which were collected during the course of sampling and those which were raised from larvae, they were identified using the standard morphological keys, which are described by Gill 1972. Simpson's index of diversity was calculated. Now for molecular identification, the mosquitoes were pooled and homogenized, and the total DNA extracted using the DNA tissue extraction kit, and the master mixes were prepared, and the amplicons they were prepared. Then the PCR was run, and the amplicons were analyzed using 80% agar-scale electrophoresis. Next. Next, I can say all our 3 sampling strategies, they yielded positive results. Now, it can be observed that much of the mosquito larvae was collected from actually 3 types of mosquito breeding containers, which included plastic, the metallic, and the earthen pots. These ones were actually much abundant within the community. However, for like in Suka autonomous community, we also collected more mosquito larvae from used car tires and wooden containers. Next. And I can also that the method which collected the highest number of alert mosquitoes, it was actually through level sampling. The ones which emerged were actually the majority. However, other methods, that is the HLC and the BG sentinel traps, they also really helped us to collect quite a number of mosquitoes. Species diversity, Aedes aegypti complex group were actually the most abundant in both the 2 communities, and that was followed by Aedes albopictus. The other 3 other species of Aedes mosquitoes which were collected, that is Aedes simpsoni, Aedes leucocephalus, and the Aedes tetanus, they really had a minimal abundance. Next. Now, upon amplification and reviewing the gel, we generated the gel readings. I'm not sure whether you are seeing those bands well, but we managed to detect Aedes albopictus at around 950 decibels using the target primers, and also Aedes aegypti complex group was also observed. However, the other we also ran test targeting 2 sibling species which were reported to be abundant within the West African region, and those 2 sibling species are from the Aedes simpsoni group, which was morphologically identified. Now, the primers targeting them did not really actually produce positive readings upon viewing the gel. So I can say our specific application produced mainly positive results for 2 species, that's Aedes albopictus and Aedes aegypti. Next. Next, please. Now, this study reports that actually car tires, plastic containers, earthen pots, and metallic containers, they are really the main breeding habitats for Aedes mosquitoes. And these ones have been much reported around the area by other researchers. Now, the Aedes simpsoni complex group, which was cited from the area, has also been reported in the other sites. And by the time we were coming out after this study, there were also cases of yellow fever around and dengue, and then sporadic cases. So this study confirmed that actually those the species are really abundant in the region. Also, PCR results confirmed the presence of potential yellow fever and dengue fever vectors, so which had been also reported in other studies, and this really shows that actually the area where this study was carried out is really at a higher risk of transmission of these arboviral diseases. Next. Next, please. Now, this study provides an insight into the presence of potential viral vectors, and this shows a high risk of viral transmission in the area. Therefore, there is need for a continuous and systematic surveillance of the area. There's also need for development of effective primers, which can really target the sibling species within the Aedes simpsoni, and actually, if possible, the Aedes aegypti complex groups. Next. Thank you for listening. I would also take this opportunity to thank the National Vector Research Center in Nobu, and my supervisors, Malaria Consortium, for the scholarship support, and University of Nigeria. Thank you.
Thank you very much, Amos. And just to say that those are the 5 scholars who finished the 2 years Masters in Medical Entomology. It's good to obviously see the ideas which they started with and have now turned into results. But in addition, in the motivation and the drive that they've had throughout. As we move on to the next 2 slides, I just wanted to find out if Michael Mcdonald is connected, and if you would like to say a couple of comments. Michael, are you on? Ashley, if Michael is on, please. Yes,
James,
Michael. Do you see some of the ideas? So do you have any reflections or comments?
Well, first of all, Sylvia would be very, very happy. I mean, this is an excellent, I mean, I've been very impressed with the level of science in all of these. And just to say very, very briefly, so my name is Michael Mcdonald. I did my Doctor of Science degree with Johns Hopkins from Pakistan, doing malaria in Pakistan. But I knew Sylvia since 1979, when she was a student at London before moving up to Liverpool. And I remember writing to Carrie after Sylvia's passing that I think I've shared pints with Sylvia in 14 different countries, including Nigeria, South Africa, Thailand. I replaced Sylvia twice in jobs, once on the Thai-Cambodian border in 1988, and once in Phnom Penh in 1993. And so, as I wrote to Carrie previously, Sylvia really was, she is my sister. I've gained so much from her. And James, you gave a nice description of Sylvia. And for me, she really was the epitome of how to combine science, a very, very high level of science, with compassion and with ethics. And so I think, as I said, she would be very happy to see, these projects with, with the One Health in South Africa, working with cattle, working with repellents, which obviously is one of the techniques of the future, traditional herbs, mites and urban health, and of course, Aedes, which are a growing problem in Nigeria. And also, just to say for our colleagues in Nigeria, I was married in Imo State, right next to you. I was married in Owerri many, many years ago. So I also have a romantic relationship with Nigeria. But let me just finish by saying that, again, Sylvia would be very happy. The level of science, the level of creativity that has been shown in this. And so grateful to Malaria Consortium that her legacy lives on in such a very tangible and creative way. But let me stop there, James.
Thank you very much, Michael. And Nathan, we'll get to you. I just wanted to ask Dr. Audu if he's on, if you'd like to say anything, Dr. Audu. Dr. Audu, Mohammed, are you online? Ashley?
Yes, I am.
Yes, please. You see how these ideas have all turned out into results.
Yeah. Okay, so I'm Dr. Audu Bala Mohammed. I'm the National Coordinator, National Malaria Elimination Program. It is my pleasure to attend this webinar to showcase the awardees of the Dr. Sylvia Meek Scholarship. I also recall on the 26th of January 2018, I joined the team to Malaria Consortium for official visit to University of Nigeria, Nsukka, where Dr. Sylvia Meek Scholarship for Entomology was awarded to two successful candidates. That was Pumilayo and Amos. The ceremony was attended by the principal officers and top management of the university. Now, it gives me great pleasure to join once again to participate at this webinar on an occasion of this Dr. Sylvia's Meek Scholarship awardees are now ready to join the national and international professional community to work towards the elimination of malaria and other diseases of tropical importance. I want to remind our awardees that their academic qualification and the follow-on of professional work is an honor to Dr. Sylvia Meek, an entomologist who live a life of deep professional knowledge, dedication, commitment, passion. Her worthy personal and professional attributes are embedded not only in Nigeria, but across malaria and its control communities all. The next generation of entomologists, Dr. Sylvia Meek scholars, need to demonstrate professional community stakeholders that they now have what it takes.
Sorry, Audu, you're a bit distant. Are you close to your mic?
So I congratulate Malaria Consortium for supporting this development initiative and the University of Nigeria for training and guiding the awardees till they graduate. Once again, on behalf of the National Malaria Program, I congratulate all the awardees. Thank you.
Thank you very much, Dr. Audu. Okay, now moving on to the next, the final two presentation. Another presentation from Thailand University. Somsanit, over to you. Yes, Nit? Yes, I think you might be on mute. Try now. We can hear some, yep, if you could try. We can, but your voice is a bit distant. We can't hear at all. Put the phone closer to you and see if that works. Yep, put it closer.
James, she appears to be on mute from what I see.
Yeah, she is. I think, yeah. Ashley, I think, yeah, to see whether there's what you could unmute on the on Zoom. Okay. Okay, there seems to be a bit of a problem. Okay, could we then move to the next presenter as we try to resolve that, Ashley? Nit, let's try and resolve that. Okay, let's resolve that. So let's move to the next presenter. Katjois, you can do your presentation and then let's see if we can resolve Nit's presentation. Okay. All right, Katjois.
Hello,
over to you.
please. Can you hear me?
Yes, we can.
Okay. Next, please. Sorry. Hello, I'm Ketiot, and Greetings to all of the participants and everyone in here. Please go back a bit. The topic in my study is the vector transmission occurrence of Aedes mosquito in monkey and man coexist area in Prachuap Khiri Khan province, which is the coastal area of Thailand. Next, please. As we know that the arbovirus is the virus that transmit by the mosquito or insect. But for Aedes mosquito, there are three viruses that are important to the healthcare problem, which is dengue, Zika, and chikungunya. Next, please. In this study area, the Prachuap Khiri Khan at the Khao Takiep, the study area consists of monkey, and as you can see in the picture, the monkey is closely coexist and can move near the house without afraid of the people in, especially if the said area is the mountain part. Next, please. Okay. For rationale that I study in here is, as we know that dengue, Zika, and chikungunya are all mainly transmitted via human in the urban area, as the picture show. However, the zoonotic cycle, which is the cycle that involve around the animals and more of the rural area, it can serve as the virus circulate point, which can lead to re-emergence of the disease even after curing as well. And it can potentially introduce some kind of a new virus to human. Next, please. Here is the study that show about the importance of zoonotic cycle. However, many study report this, and they all show the same, but no study really conduct in Thailand. Here there is some study in Malaysia or in other parts which involve the forest, but no study ever conduct in Thailand or from Thailand. Next, please. So the objective of my study is to determine the transmission factor of the Aedes mosquito in the area that human coexist with monkey. And the more specific one is to see the vector distribution and density between the coexisting site to detect the arbovirus via the RT-PCR technique and to see the risk of host vector contact as well. Next, please. This is the study site of Prachuap Khiri Khan at the Khao Takiep. As you see, the red area is the Prachuap Khiri Khan province, and the Khao Takiep is in the area number 7. This is the overall map of the study site. Next, please. As we look in, we see from top to bottom is you see the area that involve all kind of the from the rural side into more urban side, and each area is very connected. So monkey has a chance to move from the mountain, the top picture, into the human habitat, which is the fourth picture. Next, please. Here, the mosquito that I have collected mosquito from in the peak of transmission period for 1 month, which is from July 2019 to August 2019. The survey is done for the behavior and the knowledge about arbovirus of the population in the area. We study 80 houses as we shown in the previous slide that we study 20 houses for each zone. For adult, we collect the mosquito by two methods, which are by BG trap. We use 2 traps per house. For we place on Monday and collect the trap back in Friday. Every day we also exchange the bag that used to collect the mosquito out. For adult sweeping, we use the mosquito sweeping net to sweep and collect the mosquito by the skilled and experienced human for 15 minutes in every house and every day. When the mosquito is collected, we kept cold with the dry ice to maintain the virus that may in its body. For larva, we use human to collect with the dipping technique in every possible breeding place for the for each of the houses and kept in the water bottle. If the larva or pupa that we collect ever emerge, we collect and kept cold with dry ice as well. And for eggs, we use 10 OV traps per house to capture eggs for the total of 800 OV trap placed. In each house, we place 4 traps indoor and 6 outdoors. Next, please. For the mosquito that we collect, for the adult mosquito, first I use the illustrated guide of mosquito in Thailand to identify where the genus, species, sex, and the blood meal status. Then make a pool. In this study, I mainly concentrate on the ED. So this is the result of the pools that I collect. The Aedes aegypti pool is 843 and Aedes albopictus is 22 pools. Next, please. For the result, this is the, because my study is not finished yet, so this is the preliminary result. For the around 11,000 mosquito capture, majorities are Culex and E's, as you see in the by the graph. The majority is Culex first, and the Aedes is second. Next, please. Again, this is for the positive OV trap that we recover after the study. Some of the trap is destroyed by the monkey, so the count is decreased a little. The eggs found more at the OV trap that placed outdoor, but it may also because we place the trap outdoor more as well. This need some more analysis to actually pinpoint the cause. Okay, next, please. And this is for the larva that we collect in all of the study area. We collect around 1,200 larvae in per 676 container in all study area. Next, please. This is the entomological index that I plan to use for calculate for the future analysis, which is adult index, because this is for the female adult, which is the main focus of my study. All the usual 3 larval index and the infect adult index once I obtain the virus positive sample from the PCR study. Next, please. So here is the future plan of my research to add statistic analysis and include some more picture as to easily identify the place with more problem and finish all the PCR lab, which I plan to finish by around, I think around October of this year. Next, please. Yes, and at the end, I hope to answer the impact of the mammals in symbiotic cycle if it's really maintain and spread arbovirus to human, as the case in this study area, especially for chikungunya, is recently on the rise as well. Next, please. Thank you very much for listening.
Thank you very much, Katios. And we'll now try to get Nith to present hers. Let's try and see if the volume will work. If not, we'll just get on to the rest of the agenda. So Ashley, could you get back? And while we do that, I wonder whether there's anyone from the University of Mahidol, any of the tutors who are on, if there's anyone who wants to just give one or two comments. I think Ashley, get the slide back to Nit's presentation.
Can you hear me now?
Yes, we can.
Okay, thank you.
All right.
I'm sorry for the
Go ahead.
previous problem. Okay. So good evening from Thailand. My name is Somsanit Chanpetsarat. So I will talk about the dengue virus serotype 2 infection in EDSPP mosquito using nanoject 2 injector. Next slide, please. So dengue fever in Thailand has been reported from long time ago, since 1950, and the highest case is found in Bangkok. Next, please. And many researchers try to study about the viral transmission and try to apply the appropriate method to get more understanding of virus and its vector competence by using artificial feeding or intrathoracic inoculation. And in this study, we use nanoject 2 injector to inject the virus to Aedes female mosquitoes because we would like to determine whether which volume had the highest rate of the infection. Next, please. So our objective is to determine dengue virus infection in EDSPP using nanoject 2 injector. And specific objective is to select the capable mosquito colony for viral inoculation and to observe the new equipment of nanoject 2 injector for dengue virus serotype 2 infection in EDSPP by intrathoracic inoculation and to compare dengue virus serotype 2 infection in EDSPP. Next, please. And this is our material and method. First, we collect the mosquito and colonize in the laboratory. After that, we identify the adult and we select the Aedes mosquito for viral infection. And after that, we detect virus by using one-step RT-PCR. Next, please. So this is our material, nanoject 2 injector. Next, please. And this is the volume of dengue virus serotype 2 injection per individual mosquitoes. So we have like a 2.3 nanoliter, 32.2 nanoliter, and 69 nanoliter, and 138 nanoliter, and 207 nanoliter. Next, please. And after 14 days observation, the mosquito survival rate that we can observe for ED aegypti was 18%, and ED albopictus was 78%, and ED scuteris was 17%. Is very low. Next, please. For the infection rate and dissemination rate after 14 days, and we found that Aedes aegypti and Aedes albopictus had the ability to infect with the same range, about 83% to 100% of the minimum volume as 2.3 nanoliter, whereas Aedes scuteris show only 40%. So however, Aedes scuteris is increased up to 100% at the volume 69 nanoliter. And for the dissemination rate, this one we pull legs together and we found that 100 of infection in all volumes of each species. Next, please. So in conclusion, the result, they demonstrate that dengue virus serotype 2 infection and dissemination rate of all 3 Aedes species, even though they were infected with only minimum volume. And the result will be support the public health concern strategy, and Aedes scuteris might be the one of the dengue virus vector in Thailand. Next, please. And this is the recommendation from our research. The confirmation of ability of viral transmission rate in EDSPP for the further study. As the previous study, we only study about the body infection and the dissemination rate. And the study of viral transmission by Aedes scuteris should be studied more. Next, please. And thank you for Dr. Sylvia Meek Scholarship, Malaria Consortium that support me and also my committee. Next, please. Thank you very much for your attention.
Thank you very much, Somsanit. As we get to the questions, I don't know whether any of the tutors from Mahidol University who would like to say something. I haven't identified any on the participants, but if so, please raise your hand and they can unmute you and you can say a few words. As we get on to that, I think for the first presentation, Takalani,
yes, James.
There was a question that said what software you collected data on, what software you collect data on the files and software to analyze.
Okay, thank you, James. So I'll just start off with the statistical software. For the survival study, I used the Cox proportional hazard model, which is from the statistical software R. And then for the egg production part, I used generalized linear mixed models from SPSS. And then for both parts of my study, I used Excel to collect data. And then I saw there's a second question directed to me as well.
Yes,
can I
please.
just somehow answer all the questions?
Yes, you can. Yes, you can.
Okay, so the other question was, okay, I'll just read the question first. Did you evaluate the acquired resistance of Anopheles to the products? Okay, so I'll answer that. I didn't, there's a second part of the study, which I didn't present on, so it's a separate presentation. So for this part, we investigated the social acceptance and practicality of use of these insecticides in one of the malaria endemic regions in South Africa. So this we did via the use of questionnaires. So as part of the questions, we asked the cattle owners about the type of insecticides that they're already using, because we wanted to see if there is a link between the active ingredients that are in the insecticides in my study and the insecticides that they that are already being used in the region, and we did not find any similarities. So I don't think there's any resistance since the insecticides are not currently being used in the region. Yeah.
Okay, thank you very
I've
much.
answered the question.
Yes, you have. Thank you very much,
Okay. Thank
Takalani.
you. Thank you.
Fumilayo, there were some questions for you. Do you want to take on some of them? There was something about what are some of the challenges that could be encountered in the adoption of the studied plant extract as insecticides for malaria control? It's a difficult question, but make an attempt if you want. Fumilayo, are you on?
Okay. Hello. Can you hear me now?
Yes.
Okay. Yes, I saw the question about a few minutes ago.
Yes.
Yeah. So let me just say this. I'll try to answer it based on the challenge I faced when I was gathering my plant materials. The question says that what are the challenges that may arise as a result of the use of plant materials? I believe the availability of it will get to a stage where I don't want to use extinction, you know, it will get to a stage where we'll have little or a kind of low availability of these plant materials. But at the same time, we can actually overcome such a challenge using the artificial method of just having a kind of ranch, so to say, to have enough plant materials to harvest for the extraction of phytochemicals in the plant. I'm not sure I've answered that question. And I think I saw one other question on
something about that the plant repellents are also present in
the
southern part of Nigeria.
Yeah, some of them are also present. I gathered the first one, that is the sky flower, yes. I gathered some of them in the southern part of Nigeria, yes. So that is very, very true. Some are present in the southern part, while some are also present. The reason I mentioned the northern part of Nigeria is because that part of Nigeria, they basically use traditional methods for control. And some of them, you know, they have this idea that they cannot use insecticides. They believe insecticides are still very, very hazardous to them, especially for young children. So that was why I focused my attention on gathering from there.
Okay, thank you very much, Fumilayo. And then Amos, there were a couple of questions for you in terms of distribution. If you have, if you can turn on your mic, if you could answer that. There were a couple for you from different directions. So you're in the hot seat, over to you.
Yeah, the other, I think one question that I remember was, if there is a pattern of distribution of breeding reservoirs, yeah, I cannot say like there's a pattern because my research didn't really emphasize that. I didn't go into those specifics. But if I could use like the data on the map, the geographic data that I captured, I don't think whether there is a pattern. And then the other question was if there was a possibility of the two aided species having not breeding in the same container. That is, yes, they were Aedes aegypti and Aedes albopictus. They were actually collected from the same breeding containers. And then the third question was, of what importance is like my research to entomological surveillance. I can say I aimed at developing some kind of a simple PCR assay which can really target the Aedes mosquitoes, and I can say this can really fasten up the process of entomological surveillance The other advantage it can be, you don't need really to collect huge samples of mosquito adults from the field, but you can really sample a few and run a PCR using the target primers which are coming up and report the results. I think that's it.
Thank you very much, Amos. I think those were the most of the questions. If there are any questions that haven't been answered, we'll try and get answers from the scholars. The intention is to ensure that the presentations as well as the recording will be available online, and we'll also put a profile of the scholars as well online so you can access that and sort of get a feel of who they are and their background. Just before I move on to Carrie, I just wanted to check if there was anyone from Mahidol University. Otherwise, could I then, I've noticed that David Bradley is on. David, if you do want to say something, we can also give you a minute. Mahidol, any tutor from Mahidol? David Bradley, any comment, any question, reaction? Okay. Leo Brack, do you want to make any comment?
Can you hear me?
Yes, we can.
Hello, everyone. Hey, guys, you did extremely well. What a wonderful professional and enthusiastic set of presentations. Well done to each and every one of you. It's a privilege to listen to and see your confidence. You guys are ready to embark on a very successful career. So I'd like to address you specifically as a group and just say, I think you're a very special group of people, an exceptional group with talent and ability. That's abundantly clear. So just to tell you, each of you is here with us today because you were part of a competitive selection process, not just a random group of any students, but people of above average ability, each of you. I've come to realize, and I know that each of you has inside you the ability to excel in your careers. You've shown us the seeds of that in your delivery and presentations and professionalism today. So you're busy completing your master's degrees, and hopefully some of you will follow up with a PhD. But after that, it is up to you. And if you truly want to excel, please indulge me just to say these few words. If you really want to excel, you must show three things: a passion for your work, energy, and always an interest to learn more about what you are doing. So please, choose a field that interests you. Don't just let it be a job. It must be your hobby, your passion. I think if you show passion in what you're doing in your career, then and you have drive and energy and a desire to learn more about your particular field, you will succeed, I guarantee you. But please be careful in choosing what theme, discipline, topic you want to start off in the next few years, because it will probably determine the pathway that you follow for a good number of years. Make sure it's something that interests you, because that is where the passion will arise. So good luck to all of you, and thank you for the privilege of having worked with you.
Thank you very much, Leo. Carrie, we'll get to your closing remarks, and you can take 5 minutes or above 5 minutes. We can we can go over the 90-minute slot. So I'll now like to invite Carrie to say a few words. Ashley, you need to unmute.
There we go. Can everyone hear me now?
Yes, we can.
Excellent, excellent. Well, I'm overwhelmed. It's just been an extraordinary morning. And really, it's good afternoon, evening, morning, wherever everybody is. So back to the title, the next generation of entomologists, what the future holds. Well, it's just looking rosy. You know, it's really wonderful that the Malaria Consortium have asked me to talk on the webinar, and I'm very grateful for that. I shall say congratulations to all our Sylvia Meek entomologists. You're an elite and rare group, and you know, you've done her name proud. I've really enjoyed the presentations of everybody's work. I mean, there were quite a few today. I was expecting 5, we got 7, so I was really impressed. So thank you, all of you. And yeah, you've all worked so hard. You know, it's sort of, this is sort of cutting edge science. You know, it's the start of your careers as entomologists, potentially, hopefully. Yes, so, you know, the science is absolutely key. You're motivated. I think that probably goes along with being entomologists. There's a certain trend going on here, having had a very motivated sister who started off her entomology life. Maybe you know this already, but I'll remind everybody, it's sort of her route was in through zoology. She studied her BSc at Oxford, carried on to Bangor University, which is a university in Wales, to do an MSc. So that's the level where you're at the moment. And then she carried on to Liverpool to do her PhD. And I'll indulge a little bit. I don't think you can see this on the screen. For anyone thinking of perhaps doing a PhD, further study, this is Sylvia's thesis. And I don't know, probably you can't see, but it's 1982. And there's mention on it about the, I think you pronounce it Aedes mosquito. So yes, that little fella's still around, obviously. Yes, so I guess that's as relevant today, that thesis, as it was in 1982. So that was her route in. You know, I think it was just Leo Brack who just spoke a minute ago, and he was saying about fascination and interest in your subject. For Sylvia, she never lost that interest in entomology in her, you know, her subject. You know, it was a lifelong fascination to her. And, you know, I think it's very true. When you go on to your future careers, choose something, choose an area that you really enjoy and you really want to work in. Sylvia's motivation and the key areas are terribly important to her. And, you know, we've mentioned and touched on this today. Science, the absolute science is the rock solid science. And you've all you entomologists who presented today, you've demonstrated that with your methods, conclusions, your studies. It's absolutely essential. That's the backbone of all this work. Education. I mean, the whole scholarship is education, and Sylvia was absolutely passionate about education and mentoring. And you know, if she had a PhD thesis or just comments to make, she was passionate to do that and give the feedback. So terribly important. And I think, as everyone probably knows, empowering communities in her field was very key to the sort of success of the work she did throughout her life, and certainly with the Malaria Consortium. which also from 2003 when the NGO was set up was a complete passion for her, and was a joy really in her life. It was hard work, and if I had to sort of give our new scholars any sort of what Sylvia would say to you today for your future, you know, she would certainly be questioning and listening to all your presentations, congratulating you. She would definitely say, follow your interests, your specific interests, because, you know, that's what you're going to be working in for sort of many years to come. Expect the frustrations. Nothing's easy in life. There will be frustrations. There will be hard work, travel, tiredness. But the main thing is what you can do is you can make a difference. You know, you can help vulnerable people. You can move the science on, and you will. You know, you will make a difference to people's lives. So. What else would she say? Yeah, there will be challenges, and we can see that sort of as we speak. There's new challenges out there with the COVID-19, but there will be other diseases. There'll be the diseases we all know about. The malaria has to be not forgotten about. Well, no, I'm sure it wouldn't be, but it just keep resurgence down, and be aware of the sort of the up and coming problems with the vector-borne diseases like dengue. You know, it's a movable challenge. It's sort of all these vector-borne diseases and infectious diseases, they're not going anywhere. And I think just the whole, you know, it's just another layer of work and complication when we get a major sort of pandemic like we have now. So this is the part of international health and the work you do. So, but that's the interest as well for you. So somebody once said that Sylvia led from the back, so no one was left behind. It was a very sort of, yeah, a lovely remark, and I think you know, throughout your careers, that's something to hold on to, and it's going to be an exciting journey for you all. So I really think, you know, you're just at the start of your careers. When Sylvia was about your age, I remember her once saying to me, she said, I think she'd just done her PhD, and she said, Carrie, there's one thing I just want to be an expert. I don't really mind exactly what it is, but I just want to be an expert in whatever field. And yes, I think she achieved that. And I think all of you scholars are definitely going to achieve that too. Anyway, so the scholarship itself, well, let's go back to 2016. I remember going to the offices, the old offices at Development House in 2016 to see Charles. And this was the first time he mentioned about the scholarships. And here we are, 4 years later, 1st of July, hearing about 5 already new completed MSc scholars, and two more well en route to getting their scholarship, their qualifications, their MSc. So, you know, it's been a long journey, and this journey, it's sort of, it doesn't happen by accident. It happens with hard work and planning. And you know, the universities have to be thanked. Mahidol, Pretoria, the University of Nigeria, who've all engaged so well with the scholarships, and you know, looked after you, the students and the tutors. There are a lot of people involved with these scholarships, I know a lot of the names, but I don't think I'm going to list you all here. You know who you are, and it's a you know, a credit to the Malaria Consortium. It's a credit to the university. It's a credit to the tutors, and definitely a credit to you students who've engaged so well and put so much hard work into your studies. So it's finally, I just really wanted to say thank you to the Malaria Consortium. James, Charles, I know a lot of you at the Malaria Consortium. I am so proud of you all. I'm so proud how you take this world-leading organization to just greater heights all the time. Sylvia was its co-founder, and she would be so proud of you all if she was here now, and to know where you're working and how you're progressing and how you deal with every sort of hurdle that comes your way. Obviously, at the moment, it's working from home and trying to keep on top of all your work when there's all the other problems around, taking, all sorts of time away. So she would be proud of you. And the thing is, with the scholarship, it truly embodies so much that was important to Sylvia herself. The education factor, the science, it was the humanity of it all, to help vulnerable groups of people. It is just the perfect tribute to Sylvia, and it truly ensures her legacy continues to leave a lasting impact, and it will be a safer and kinder world, and you have a lot to do with that, all of you. And I think I just say very best of luck to everybody, to the Malaria Consortium. Very nice to hear people speaking like Michael Mcdonald and Dr. Aldu and whoever else is out there who I know, I'll say hello. I don't know who's out there, but all the very best with your important work, and very, very good luck to all the new Sylvia Meek scholars. And well done, well done. Thank you. And on that note, I think I better go back to you, James.
Thank you very much, Carrie. Thank you very much. So thank you all for participating in the webinar. Thanks to everyone who've made the scholarships possible, and we look forward to the opportunity to host a few more scholarships in the near future. We wish the scholars much success. And as I said earlier, a recording of the webinar will be available on our website within the next 24 hours, and we shall put some additional information about the scholars. We wish you a pleasant day. Bye.
Bye.
Thank you.